All right. It's working. Okay, so I guess if anyone's watching this video, or show a thing back here where basically like the problem from our problem set, where there's two strings, and then here's like a block hanging from 75 and 38.
It's 60 kilograms.
Okay. This is number 43, by the way. 60 kilograms. And the question is just what's the tension in each rope? And so what I showed back there is I hung a block from two strings, and there's little spring scales on them that show the tension. And what we saw was that this rope has much more tension than this rope. So before we do any calculation, there's a simple reason for this. Okay. The reason is that what is the net force horizontally for this system? If I looked at just the horizontal forces, what's the net force horizontally? 0, right? It's in static equilibrium. So therefore, this guy's horizontal component must be the same size as this guy's horizontal component. Do you agree with that? But wait a second, this guy points in this direction, this vector points like this, so his horizontal component tends to be pretty big, right? So if I draw these components, this guy pulls to the right quite a bit and up not so much. But in order for this guy's horizontal component to balance out, he's got to be a pretty big vector, doesn't he? That's the reason. How do you feel about that?
Makes sense.
So, quick recap of the argument. It's a simple argument, but it might not make sense the first time you think about it. It's because we know that these two vectors, these two components, these horizontal components have to be equal to each other. So in order for this guy that points mostly up, in order for his horizontal component to be able to balance his horizontal component, he has to be a lot longer than him. So that's the only way it's going to work out. So, but also, physics, maybe you make an intuitive argument like that, kind of what we call a hand wavy argument. You kind of go, oh, well, it makes sense because this is that. And then you prove it mathematically. Okay, let's do some math here. Let's give these variables. What should I call this one? T2, okay, or sure, TA, or if this is A and this is B, maybe you call this, as long as you know that it has to be different numbers or different variables. So this vector will be, I don't know, T sub A. And this guy will be T sub B. Those are my two vectors. Okay. So now how big is that angle right there? 38 degrees. And so, and of course this angle here is 75 degrees. Let's do horizontal in blue and then vertical in red, I guess. So this vector here, this horizontal vector would be TB times cosine of 38. And this guy over here would be TA times the cosine of 75. How do we feel about that? Try to move this a little bit closer. Anyway, hopefully that helps a little bit. Okay. Yeah, then we're going to set those equal. So I guess we might as well do that here. Let's just knock that out here. So I can write that T sub A times the cosine of 75 is equal to T sub B times the cosine of 38. Okay, so I got one equation ready to go. I'll use red for this. Let's do the vertical components. This guy would be and this guy would be T sub A, and times the sine of 75. Okay, so feel good about that? So now my second equation is going to be T sub A here's a, let's avoid a mistake here. Some people will just go, that equals that. That's crazy. That's not true. This one clearly looks longer than this one, but what's the relationship going on here?
They both try to cancel out they both were equal to 60 times.
60 times G, right? So that's 5. So don't forget your force diagram, there's gravity pulling down. So that vertical component, TA sine of 75 plus TB sine of 38 must balance out that 588. So obviously a calculator is going to be essential here. It's not unusual for someone to get stuck here because they don't realize that this is a number. Just a decimal, right? Cosine of 75, I don't know what it is, but point something, 0.3 or something. So if we take a calculator, and just type in, like, for example, the cosine of 75, 0.259 roughly. And so I'm going to rewrite this equation, or maybe you just divide this. The key is I want to be able to say, what is TA compared to TB? Does that make sense? So if I do, so you guys stop me if I confuse you here, but I can take this equation and write something like T sub A is equal to, so on my calculator, I'm going to go cosine of 38 divided by cosine of 75. Okay, so T sub A is 3.045 times bigger than TB. Let's pause there. Is anyone confused with how I'm getting from here to here? Is it okay with that? You sure? Okay. Yep. So it turns out that this number is about 3 times bigger than this number, as we can see here. So what this first thing tells us, I think when we take a quiz on this, one of the questions will just be basically how many times bigger is TA than TB? And in this case, the answer would be it's about 3.045 times bigger. Okay, so then now we can do a substitution. So I can replace, again, with my calculator, I'm going to replace this TA with that expression. And so I'm going to take my calculator now and I'm going to multiply 3.045 by the sine of 75. You guys see why I'm doing that? Okay. So when I sub that in, this is going to read 2.941 TB. This is going to be, let's see, sine of 38 is 0.616 roughly. Okay, are there any questions there? Really, no questions? This is a pretty tough question. No confusion?
I do have a question.
Yes.
Why is the 2.941 times? Oh, never mind. Got it.
Okay, well, that's good. If
Like, I guess a side column. This last question is, I was thinking, since if you know that TA is 3.045 times greater than TB, could you just re-plug that into like the horizontal equation? Just to get it, and then you can use that number as well, or?
Well, if I plug it, this is the horizontal equation. So if I plug that back in here, it would be circular. Like if you plug this back in here, it's going to end up just saying TB equals TB. Well, like, let's do a flashback to algebra 1. You remember these questions where it'd be like x plus y equals 7 and 2x plus y equals 12, something like that. And a lot of times what students do when they first encounter these, they take one of the equations, and they go, okay, y equals 7 minus x. And then they plug that back in to the equation they used to get that. And if you do that, you get x plus, now my y is 7 minus x. But that just says 7 equals 7. So that's circular. So if you use that to show that and then plug that back in, it's just going to put you in a loop, and you get a true statement, sure. But if you want to solve for x and y, you have to take this and plug it into the other equation. So that's, you can try it out yourself. I mean, yeah, if you replace this TA with 3.045 TB, this will just end up reading TB equals TB. So anyway, you got to plug it into the other equation. So, okay, so we're all cool with how we got the 2.941. And we're all cool with how we get the 0.616. Okay, so now add this many bananas plus this many bananas makes, it's too early to add these numbers.
3.55.
3 point what? I'll trust you.
557.
Okay. 3.5. You just got it. I think we're all capable of adding those up, but it is early. TB equals 5. We're almost done. Getting TB. So now TB emerges. So 588 divided by 3.557 gets us 165.3. Huh?
Now you have to multiply that by 3.045, right?
Yes. So yeah, make your life easy. You certainly could plug this back in here and solve, but it's much easier to use this. So I like that idea. Let's plug it in here. So T sub A is just that number, the TB number, times 3.045. So it turns out that number is about 503.3. And there we go, we're done, we got our answer. That's our final answer. Okay. Now, something worth noting is, what do you get if you add up this number and this number?
It's
It's what? I think Winslow got it.
It's greater than 588 newtons.
Exactly. So those two numbers add up to more than 588. So something to keep in mind. That might not be super obvious why that would be the case, but yeah, so because you could think maybe they're like wasting some of their effort just pulling the block left and right. So it would be like, imagine this, you could kind of imagine you and your friend trying to lift something. Well, if you really wanted to be as efficient as possible, you would just pull straight up. So if you pull to the sides with the goal of lifting a thing straight up, you're going to end up exerting more force than you have to. So that's what's happening here. So the strings have more tension than they would have if they were just pulling straight up. Okay, does that make sense? Everyone feel good about that? All right, so we'll have our quiz will be on Tuesday. So you'll have the rest of today, and then tomorrow, have a work day tomorrow. I'll post the practice quiz. Monday, we can go over the practice quiz as a class, and then Tuesday, we'll take our quiz. And then Thanksgiving break.
Thanksgiving break.
Yay! Isn't that great? You okay over there? Okay. What?
Our 5-day break.